Good morning, all. I'm audible.
Yes, sir.
Okay. So, if you remember in the last lecture, we discussed about types of follower motions, and we started one motion that is a follower motion when it is moving with a constant velocity. So, first motion we discussed that is nothing but a uniform motion of a follower we discussed in the last lecture, and today we'll see its next types. Okay. Screen is visible to you. Hello.
Yes, sir.
Okay. Uh, so I just briefly revise what we discussed in the last. We discussed about a uniform motion and for uniform motion the displacement diagram of cam and follower is like this. When the follower displacement is plotted on a y-axis and cam rotation, that is cam angle theta, is plotted on x-axis, then we consider three periods of follower motion. The first one is rise, dwell, and return. For this, our graph is like this. So there is follower rise first, then there is dwell, and further return. So this is your displacement diagram. With reference to this, we seen equations for follower displacement. That is for y, displacement of follower is given by at any point at any cam angle theta is given by s upon theta o into theta. So this is your equation for displacement. Then from this equation we find out displacement value at different angles. At theta is equal to 0. We know this one is theta o. This one is dual angle theta d, and this one is theta r. You can zoom your screen to see this in clear. So theta o, theta d, theta r. Then for this we find out value of y at different angles. Then from this we determine equation of velocity, and we know that velocity equation is, if I differentiate this y with respect to time, then I get velocity, and that velocity equation is, anyone can tell me that velocity equation? It is s upon theta o into omega. So we've seen here all terms in this equation are constants. So velocity is equal to s upon theta o into omega. And as it is constant at different points, so we can check at theta is equal to 0, theta is equal to theta o, or at any angle, its value remains same. Then further we determine equation for acceleration, and we know as the velocity is constant, acceleration is equal to 0. Then we draw a graph for this. I'm not going to repeat that graph, but we've seen in the graphs, the velocity curve is constant. Okay, I will draw it. So the velocity graph is constant value, then it becomes 0. It remains 0 during dwell. Again, during return period, it is constant value, but of in opposite direction. So this is your velocity curve. And then we draw an acceleration. So this one is velocity versus theta. For acceleration, as this velocity is constant during rise, so in acceleration, this velocity is constant, means acceleration will be 0 here. During dwell also it is 0, and during return also it is 0. So this is your curve for acceleration versus theta. And we've seen at the start of the rise stroke, means at this point, and means at the start and beginning, at the points I'm drawing at these points, the acceleration will be infinity first, then reaches zero. Similarly, here also it is negative infinity as it is moving towards v2 minus v1. So it will again move into negative infinity and again becomes zero like this. Here it is v1 is zero and v2 is minus. So minus, so it will be negative infinity and again zero. While here it is zero minus, so it will be positive infinity minus minus plus. Likewise, which in this graph for acceleration. So in the previous lecture, we discussed about a follower motions when it is moving with a uniform motion. That is our first topic we discuss. First type we discuss. Now we have to go for next topic. That is when follower is moving with a simple harmonic motion. So second type we have to discuss. And one more thing I want to tell you, we are using some notepad device to write this. So maybe there are some difficulties today, but I will try to recover that. Through that, I will try to correct that difficulties. So if any doubt in between, you can tell me. Is it visible what I have drawn, what I write here?
Yes, sir.
Yes, sir.
Okay. So first type is here. Yes. Okay. So now when the motion is simple harmonic motion, how, what will be the velocity equations, acceleration equations, displacement diagram, that we need to learn now. I hope you know about simple harmonic motion. When the motion is periodic motion, when it repeats after a periodic time, that motion is called as a simple harmonic motion. Or in simple harmonic motion, we know that acceleration is proportional to, this is basic equation of SHM, acceleration is proportional to displacement from mean position. Okay, so we know about simple harmonic motion. Now we use this motion for a follower displacement. So first question is in SHM, that is simple harmonic motion, how to draw displacement diagram of a follower in this case. So first step, remember, in order to draw displacement diagram, we know that displacement diagram is drawn by considering follower displacement on y-axis and cam angular displacement on a x-axis. I am telling you step-by-step procedure to draw displacement diagram when the motion is simple harmonic motion. So remember, in a given problem, a follower displacement is given to you. So we need to draw a semicircle on y-axis, and the diameter of that semicircle is equal to lift of the follower. So in a numerical, lift of follower is given to you. Lift means follower displacement is given to you. You have to draw a circle I will not say circle, but I will say semicircle. You have to draw a semicircle of diameter is equal to lift. So I will try to draw a semicircle here. So this is a semicircle, and the diameter of the semicircle is equal to, you can see this distance is equal to lift of the follower, is equal to lift, or you can say S. So on y-axis, you have to draw a semicircle equal to lift of the follower, first step. Then on x-axis, I have to draw a cam angle. Now in the numerical it is given, there will be first rise, dwell and return. So first of all, let's say consider rise here, theta O. Outstroke angle, you have to mark that angle here. So this will be this is a theta O. Then assuming there is dwell, these values are given to you. Let's say theta O is 90 degree, theta D is some angle, let's say 30 or 40 degree, theta D, and again theta R is given to you. So according to that, I will draw a cam angles on x-axis. So first step, while drawing displacement diagram, on y-axis, draw a semicircle equal to lift of the follower. On x-axis, mark cam angles. Now, we have to divide this semicircle into n number of parts, equal divisions. So, to divide this, as this angle is 180 degree, if I want to divide into n parts, let's say n is equal to 6. If I want to divide into 6 parts, we can divide in any parts, but all the parts should be equal. As I am dividing semicircle, so while dividing it, as it is 180 degree divided by 6, so 30 degree. So I divide this circle into 6 equal parts, so 30, 60 and 90. So I divide this semicircle into 6 parts. Let's say this first angle is 30 degree, this one is 60 degree, this one is 90 degree, 120, 150, and this is a 180. So likewise, I divide this semicircle into 6 equal parts. The procedure is clear? Hello? Are you getting or not?
Yes, sir.
Yes, sir.
Sir,
So what we did here, yes?
acceleration and displacement negative असतं ना sir? Acceleration is equal to minus omega square x.
Yes, you are talking about formula of simple harmonic motion. Yes, yes, yes.
Yes, sir.
Okay. So I just told you the motion of follower is SHM. Now important thing for us is how the displacement diagram is, how velocity and acceleration is. We come to know that point. Okay. So first step, I divide this semicircle into 6 parts. Next, now if I divide this semicircle into 6 parts, divide this distance of theta O and theta R into same parts, because during rise there is simple harmonic motion, during return also there is simple harmonic motion. Means this follower is moving with a simple harmonic motion during rise and return, not during dwell, because during dwell the follower is stationary. So I have to draw a rise and return curve. During dwell it is stationary, in this period it is stationary. So I have to draw a graph for follower displacement in this area, this theta O. How the follower displacement is, that I have to plot in this area, theta O, that is during rise I am writing here, and during return. During dwell, the follower is stationary. So therefore, as the follower is moving with SHM during rise and return, and hence divide this rise, that is follower rise, into same parts in which the semicircle is divided. As I taken here 6 parts for a semicircle, for a rise also I have to take 6 parts, and also I have to take 6 parts. Means if angle of theta is given to you, divide that angle into 6 parts, and divide theta r also into 6 parts. So first step I told you, draw semicircle. With the diameter is equal to lift. Second step you can say, divide that semicircle into n equal parts. Now in third step we can divide theta o. So divide theta o and theta r into n equal parts. And here n we taken for semicircle is 6. Therefore, I have to divide into 6 parts. So let's say it is first part, second, third, fourth, 5 and 6. Okay. So it is 1, 2, 3, 4. This is 5 and 6. Similarly, here also I have to divide into 6 parts. So this is 1, 2, 3, 4, 5 and 6. Now naming I have to give for this. Let's starting with give name into semicircle first. So it is 0 point. This is 1, 2, 3. Here it is 4, 5 and 6. So first 6 parts. And again there is this first 6 part for rise. Then for dual again this is 7, 8, 9, because it repeats. It falls down. During 12 the follower moves down. So during 0 to 6 it moves up, and from 7 to 12 it moves down. 7, 8, 9, 10, 11 and 12. Sorry, it is 7, 8, sorry, 9. Something goes wrong. This point is common because yes, it is 6 point. So this one is 7, 8, 9, 10, 11, and again end is 12. That is 0. Now here on the x-axis, this is 1, 2, 3, 4, 5. This one is 6. Now here it is 6. Again, after dual, this point is same because the follower displacement does not change. Follower is stationary. So this one is 6 again. So after 6, 7, 8, 9, 10, 11. The last point is 12. Okay. Is it clear what we did up to here?
Yes,
Yes,
sir.
sir.
Yes, sir.
Actually, I want to ask one thing. Be free. I'm using this notepad here, but I think the arrow is not visible to you. What I'm doing, what I'm writing. So is it better to use this one, or we will use our camera and conventional method? Because this is graphical, and that if arrow is visible, it is more clear. Otherwise, if it is okay for you, I'll go with this.
Sir, one arrow is visible.
Actually, that arrow is which arrow I'm saying. When I'm writing there, then it is visible. Let's say, but that arrow is not moving, na?
No, sir.
Okay, okay,
Now
okay.
it
Yes,
moves.
yes, it is move. Yeah, so I can use this arrow. Okay. Okay, then no problem. I will proceed with this. So what I did here, you understand, I first divide this semicircle, then I divide these parts into equal parts, that is rise and return. So which motion you are studying, please? Hello?
Simple harmonic motion.
Okay. And now next step after this, after dividing this semicircle into n equal parts and this cam rotation into n equal parts, next step is draw a follower displacement curve. And for this, we need to take projections. Whatever we did till now, it is all work will be faint. We will draw by faint lines. So next, I have to take projections from the semicircle on y-axis. You can see now, I am taking projections of one, projection of 1, projection of 2, 3, 4, 5, and 6 is already there. So you can take projections till here also. Okay, next step is clear. You have to take projections. Now, see, when I actually this one is, I'm showing this one. This line is projection of what? 1. So this one is projection of 1. This line is projection of 2 and 10. This one is projection of 3 and 9. This one is projection of 4 and 6. And this one, tell me, this line is projection of which 2 points?
5 and
5 and
7. 7.
yes, 5 and 7. And the last one is projection of 6. Means on that lines, these points will be there. You know the 1 to 6 are the points of rise and 6 to 12 are the points of return. So what I do here next now, draw a vertical line passing through 1, 2, 3, 6 up to 12 on a x-axis. So through 1, I'll draw a vertical line. Projection through 1, projection through 2, 3, but up to where you know that I have to draw these vertical lines. I will draw this vertical lines till it intersects projection of same point from a y-axis. So I have to draw this vertical line 1 till it intersects projection of 1 from a y-axis, from a semicircle. So you can see I drawn this 1 up to here only. Okay for me, no need to draw further. Similarly, second I have to draw up to 2 projection, up to third projection, and similarly up to 4, 5, 6. So see now how I am drawing. I am drawing this vertical line 4 up to projection of 4. It is here. You can see this 4, 6. Then up to projection of 5. And finally it is 6. Similarly, the 6th point is here. Then up to projection of 7. You can see now I have to draw vertical line through 7 till projection of 7. So up to here it is. So I am drawing projection of 8, 9, 10, 11 and 12 is here. So likewise, we will get different points like 0, 1, 2, 3, 4, 5 and 6. 7, 8, 9, 6, 7, 8, 9, 10, 11 and 12. So likewise, we get different points. And if I join these points by a smooth curve, then that curve is called the displacement curve for a simple harmonic motion. You can see this curve actually it is somewhat like this, but the curve is in this way. It is not having constant slope, but the curve is somewhat like this. So this is your displacement curve. If I join this point through a smooth curve, it will be like this. During dual it is stationary, and further so it is not a this is a smooth curve basically, not like a displacement curve of a uniform motion. So this is your simple harmonic motion displacement curve. You can zoom that diagram to see it carefully. Okay. Any doubt in displacement diagram? How to draw displacement diagram? Important one, because remember in CAM profile drawing, now we are discussing graphical part as well as theoretical part. Means after this displacement diagram, I will discuss velocity and acceleration analysis of this motion. So if you know displacement curve, then we will go for velocity and acceleration. Okay, is it clear? Any doubts?
No, sir.
No, sir. Can anyone repeat that procedure so that I will get confidence that you are getting? Step by step procedure. Yes? No one can tell me? Okay, I will explain. You again try to remember or understand.
Sir,
Yes?
sir,
करू का explain?
Yes, yes.
Sir, first we have to draw x-axis, y-axis. Then on y-axis, displacement. On x-axis, theta. Then draw a semicircle on y-axis. Divide it into n parts. We take here n as x. Then on x-axis, yeah, we have to divide as it is at theta 0 and theta r. Then
Don't call it as,
connect
you're
the.
right. Don't call it as theta 0. Call it as theta O, outstroke. Theta O, outstroke. Angle during outstroke. Okay.
Okay, sir. Theta
Uh,
O. Then intersect the lines parallel to x-axis, passing through the semicircle point 1, 2, 3 respectively, and the on x-axis the point 1 to 3 parallel to y-axis. Join these points and draw a curve through these points.
okay, good. That's what I'm expecting. I hope others also, those are concentrating, they might get this. Okay. Now see, the next step is, next procedure is, we have to analyze the simple harmonic motion. That is, we have to find out equations for displacement, velocity, and acceleration. Remember, this topic is very important for analysis of CAM design. Means how to get these equations. So for this, let's say assume that you know the simple harmonic motion. We assume that, so for analysis part, I'm saying analytical solution for calculation of or determination of displacement, that is yes, velocity, acceleration, and jerk of follower having SHM. So we are finding this when this follower is having simple harmonic motion. Now let's say consider okay, actually I drawn this, but it might be not visible to you. So I'm again drawing here. So what I consider, let's say this is center of this circle. Consider any point P at any position. So this is particle P. So what I consider a point P moving on circumference of circle. So I consider this point P, which is moving on the circumference of circle with constant angular velocity. So this point is P at this instant, it is here. If I project it here, then the displacement of this point is given by its projection on y-axis. So I consider point P moving on the circle with constant angular velocity omega. And we know that, let's say theta, when cam rotates, that is when cam rotates, the follower is moving up and down. When this cam rotates, the follower is moving up and down. So, and it is, we consider it as SHM. So it is just similar to this circle. This circle is called as a harmonic circle. So if I consider any point here, let's say point 1, 2, 3, 4, 5, 6, 7, at this point I consider, so it is just this circle I drawn is similar to this circle, harmonic circle. So at any point, when cam turns to angle theta, then theta O or theta means when it turns to any angle theta, what is follower displacement that we need to find out. And to find follower displacement at any instant, we know that when this cam rotates at angle through angle theta, the follower is moving in a vertical direction. So the projection of this point on a y-axis gives you follower displacement. I repeat, projection of this particle P on y-axis gives you follower displacement. So to find out that, we know that, let's say, initially at this point, at the bottom of the circle, this point, the velocity is, displacement is zero. And at this instant, this particle P is here. So if I project it, the follower displacement is up to here. So let's say I'm drawing it, the projection of this point here. So at any instant, when cam angle turns to angle theta, when cam turns to angle theta, its displacement is y. So this displacement is y. This one is y displacement when this cam turns through theta angle. Now on harmonic circle, remember when cam turns through this theta angle, this is theta angle, the point on semicircle is at some angle from this vertical axis. How much that angle is? Let's say theta is equal to 0, the follower is here. At theta is equal to outstroke, let's say theta is equal to 180 degree, complete outstroke, the follower is at highest position. So this angle, this complete angle is theta O, it is theta 0. So I can write at any instant, the angle turned by point on a harmonic circle is pi upon theta O into theta. This is important to understand. I'm saying that angle at any instant, angle at any instant, but angle, whose angle? The angle of, I'm saying angle of particle P. At any instant on harmonic circle, is, how much it is? This pi upon theta O into theta. Pi upon theta O, okay, it is not visible, okay, is pi upon theta O into theta. You can see at theta is equal to 0. When theta is equal to 0, how much this angle is, complete angle is? Yes, some students might be confused how this angle is pi upon theta into theta. You can see at theta is equal to 0, complete angle this much. At theta is equal to 0, this angle becomes 0, so it is follower is here. At theta is equal to theta O, outstroke. So this theta O it cancel, angle is pi, means this circle, this follower is here. So at any instant, this angle is pi upon theta O into theta, where theta is angle turned by cam, and this complete angle is angle turned by point on a harmonic circle. Now, why I am finding this angle? Just for purpose of finding follower displacement. So now let's find out equations for this. You can take screenshot of this because after some time it may not be visible to you. I'm going to change this page. Okay, so what we discuss here is, I consider one point P on a harmonic circle here. let's say center of the circle, this is point P. The angle turned by the circle is pi upon theta O into theta. So I have to find out displacement. You know that this complete displacement is the polar is moving from this point 0 midpoint to S. So this complete displacement is S. At any instant, this distance is y, polar displacement is y, and hence I can write, if you see in this, if it is S, means this complete distance is S, then half distance is S by 2. So this one is S by 2. The radius we can say of this semicircle of the circle is S by 2, and hence y is equal to, what I can write for ys, anyone, in terms of this angle and s displacement, what is the equation for y? Observe the geometry and tell me. Displacement of follower at any instant is how much? Yes. Hello. Yes, can anyone tell me the equation for y from the geometry in terms of displacement and that angle? Yes. It is very simple. You
S
observe
by
here.
2.
Yes, yes, please.
S by 2 minus S by 2 cos pi theta by theta
Of that
theta
angle.
theta O.
Good. I think Nilesh Bhate. Okay. You can see this one is y. So this y is equal to this complete distance, that is s by 2 minus this distance, upper distance. How much that distance is? So this distance, you can say this s by 2, this s by 2 minus this distance. So minus this distance. Therefore, y is equal, I can write it is equal to s by 2 minus this upper distance, that is s by 2 cos of that angle. How much that angle is? Cos of pi upon theta O into theta. It is your equation for displacement of follower. And if you know this equation, then you can determine velocity and acceleration of the follower. So our basic equation for displacement of follower when it is moving with simple harmonic motion is this one. Now we can determine, now we have to determine value of displacement at different angles. So let's say find out displacement equation, displacement at different angles. So let's say at theta is equal to 0. Theta is equal to 0 means when? So find out displacement at theta is equal to 0. Theta is equal to theta O by 2 and theta is equal to theta O. You should know meaning of this. At theta is equal to 0 means at the start of the outstroke. Theta O by 2 means half of the outstroke. And at theta O means at the end of the outstroke. Outstroke means rise. So these are the displacements of the follower during rise, at beginning of the rise, at the end of the rise, and at the half of the rise. So all of you find out displacement at these points. Why? And tell me equations. Just simple one. Yes, please. Yes, we have to put value of theta in that equation. Determine and tell me.
0 s by 2 and
So at theta is equal to 0, what is value of ys?
0.
Y is
0.
equal to 0. See, at theta is equal to 0, if I put 0 here, cos of 0, cos 0 is 1. So s by 2 minus s by 2, how much it is? Yes, it is 0.
0.
Yes. So at theta is equal to 0, y is equal to 1. That is obvious. We know that. When cam angle start rotating, when cam start rotating, its follower displacement is 0. Or yes or no? At the beginning, it must be 0. Then, when the cam turns through half of the rise, half of the outstroke, when it is moving through half of the cam angle during outstroke, y is how much? Check it, please. Put value of theta here. Theta is theta o by
S
2.
by
So
2.
theta o theta would
I
cancel.
is equal
Cos
to
pi
S
by
by
2.
2.
Yes, it is.
S by 2.
S by 2.
Yes, good. S by 2. Because here you can see here cos pi by 2. Cos pi by 2 means who is Shubham Chaudhary? He's in our class. Hello. Shubham Chaudhary is in our class, means either A or B. अरे असं नावाचं कोणी आहे का क्लासमध्ये? माहिती तुम्हाला तुम्हाला माहिती आहे का ए मध्ये बी मध्ये कोणी? येस. येस और नो ऍटलीस्ट रिप्लाय इफ यू नो और डोंट नो.
बी मध्ये
आहे का?
Oh, sir.
Okay. Okay. Forget about that. Just we talk about at theta is equal to theta o by 2, y is equal to, if I put theta is equal to theta o, this cos pi by 2, cos 90. How much cos 90 is? 0. So it will be, this second term becomes 0. Only first term there. So y is equal to s by 2. Just simple it is put value of theta o by 2, y is equal to s by 2. And similarly, we can find out value of y at theta is equal to theta o, and how much it must be. Without calculation, you can tell me. It must be equal to s. Means during outstroke, follower is moving, follower is at highest position, and it is equal to s. You can see at theta is equal to 0, it is here. I'm showing on the diagram. At theta is equal to theta o by 2, it is here, which is s by 2. And at theta is equal to theta o, that is outstroke, this one, complete angle, it is at s displacement. So this is for displacement. I request you now, as you are good in mathematics, you can derive equation for velocity. So I'm writing here the magnitude of velocity of follower. And how to find velocity is very simple. I'm just telling you procedure. The velocity is equal to dy by dt. Displacement of follower with respect to time. So d by dt of y. How much y is? Yes. How much y is? It is s by 2 minus s by 2 cos of pi upon theta o into theta. So just derive this and get value of get expression for velocity. All of you please do this and tell me equation. I'm waiting for 2 minutes. I will wait for 2 minutes. Yes, anyone? It's very simple. You can see it is s by 2 minus s by 2. So we can take common. So actually it is d by dt of. Shall I explain or you are solving it? Yes? I don't think so. Okay. So d by dt of s by 2 will take common. Then it is 1 minus cos of this pi upon theta o into theta. It's very simple. So it is derivative of this term. So as it is s by 2 is constant, we know that. So I can write here s by 2 into, now derivative of 1. Derivative of 1 is 0 as it is constant, minus derivative of, actually minus sign is there. Derivative of cos. Derivative of cos is minus sign. So this become plus. So sine of this term pi upon theta o into theta into derivative of this term. So pi upon theta o constant into d theta by dt, and d theta by dt is omega. Written directly here. I hope you understand. So it is equal to s. My equation is s by 2 into pi upon theta o. So I'm writing it here. So it is equal to s by 2 into pi upon theta o into omega into sine of that angle, sine of pi upon theta o into theta. It is value of velocity. So our expression for velocity is equal to s by 2 into pi theta o into omega into sine of pi theta o into theta. So you can see here expression for velocity is sine curve, or the nature of the curve is sine curve. Velocity is having a sine curve. So it is this equation will help you to find out the graphs for displacement, velocity and acceleration. So I'm writing here velocity is equal to, yes, s by 2 into, let's say sine term, we can write in terms of sine, it is sine of pi theta o into theta into the constant term is pi upon theta o into omega. So this is your velocity equation. Now from this we can find out acceleration. So acceleration equation is, yes, of course we need to find out this velocity at different points. So let's first find out velocity at different points. Velocity at different cam angles, at different thetas. So find out at theta is equal to, same procedure we have to adopt, that theta is equal to 0, at theta is equal to half of the outstroke, and at theta is equal to theta o. So determine value of velocity at these three angles. Just put value of theta in that expression of 10. Yes, we will continue this because the two lectures are there, but I will take 1.5 hours and then tell ma'am will continue. So just finish this expression. Yes, determine value of velocity. Those are solving, they will get interest. Otherwise, those are not solving, they'll get bored because they don't know what we are doing. So everyone, I request, please solve this along with me and write this. Saga expression, all this expression I want in hard copy. You should write it along with me. Don't only enjoy the screen.
When theta is
Yes,
equal to
determine.
0, v is equal to s by
Yes,
2.
yes.
When
So
theta
at
is
theta
equal
is
to
equal to 0. Theta
v
is
is
equal to
equal
0. Sine 0 is 0. So simply it must be 0. So velocity is 0. Is it right?
Yes.
Yes, sir.
Okay. At theta is equal to half of the rise. Are you getting, when I say half of the rise means
Theta O by
half
2.
of the outstroke, theta o by 2. That's you should understand. Okay. Theta o by 2. How much it is? Sine 90. Sine 90 is 1. Hence value is s by 2 into the remaining term. S by 2 pi upon
Pi
theta
into
O
omega.
into omega. So this is your expression for velocity at, see why I am finding this values, from these values I have to draw graphs. Okay, next, acceleration. Yes, for acceleration. Sorry, for velocity at theta O, how much it is?
0.
0.
So velocity again 0, because again it's theta O means sine 180. So 180 0. Good. Means where the velocity is maximum, at what cam angle it is maximum?
Theta O
Where you
by
get
2.
maximum velocity? Yes.
Theta by
So
2.
you can write here V is nothing but V max. So velocity is maximum at theta O by 2. While displacement, where displacement is maximum? You check these three terms. Where displacement is maximum? Yes. At
Full.
theta O,
Theta
at the
naught.
outstroke, at the end of the rise. Of course, when the follower is moving gradually, at the end of the rise, at the end of the outstroke, it is maximum. But this velocity is maximum in between. At the start and end, it is 0, and in between, it is maximum. Now determine for acceleration. Yes. Determine for acceleration. Yes. Equation of acceleration. Yes. Determine for acceleration. Just take derivative of velocity. Yes, anyone?
S by 2 pi by theta naught omega whole square cos of pi by theta naught into theta.
Okay, good. So it's very simple. Just when you take derivative, okay. So for acceleration is nothing but dv by dt. A is nothing but dv by dt. And we know equation for velocity is, so it is d by dt of, what is our equation? If you remember, it is s by 2 into sine of that angle, that is pi upon theta o into theta, into that constant terms, it is pi upon theta o into omega. I hope it is right. And hence I can take all terms, constant term to outside. So it is s by 2 constant, then this pi upon theta o, omega is constant or not? Whether omega is constant? Yes or no? Those who are listening carefully, I told you at the beginning only, we assume that the cam is rotating with constant angular velocity. So this omega is constant. So it is s by 2 into pi upon theta into omega into derivative of this term. Sine derivative is cos. So it is cos of the angle, cos of pi upon theta into theta, into, yes, into derivative of this. So this term is constant again, pi upon theta into derivative of theta. So derivative of theta is d theta by dt, nothing but omega. And hence we get it is s by 2 into this pi upon theta here, pi upon theta here. So it is pi square upon theta o square, omega into omega is omega square, into cos of pi upon theta o into theta. This is your expression for acceleration. Now from this, determine value of acceleration at different points, like acceleration at theta is equal to 0, theta is equal to 0, at theta is equal to theta o by 2, and at theta is equal to theta o. So get value of acceleration, and from that we need to draw curves for displacement, velocity and acceleration. So determine value of acceleration. Also we have
Sir,
to draw,
at
yes,
0 it's maximum, and at theta by 2 it's 0, and at theta
yeah,
naught
right.
it's minimum.
Okay. It is also maximum, but in opposite direction. Okay, negative. Okay. So what I can say now, at theta is equal to 0. So cos 0 is 1, and hence its magnitude is, this term becomes 0. I am saying cos 0 is 1. So this term becomes 0. Other term as it is. So at theta is equal to 0, the acceleration is s by 2 into pi square upon theta o square omega square. So it is value of acceleration at theta is equal to 0. Now at theta is equal to theta o by 2. Just put theta o by 2 here. It is cos theta o by theta o get cancel. Cos pi by 2 means 90. Cos 90 is 0. So at theta o by 2, acceleration is 0. The cos term is 0. And again at theta o by at theta o. So it is nothing but put this theta is equal to theta o. Cos 180 means minus. So it is same as theta is equal to 0, but in opposite direction. So it is minus s by 2 into, it is similar to this one, it is pi square upon theta o square omega square into cos of pi upon theta o into theta. So this is your acceleration value. Magnitude of acceleration at theta is equal to theta o. So acceleration is maximum where? Yes. So A is equal to mx at theta is equal to 0 and theta is equal to theta o. Okay. Similarly, try to find out jerk now. The next term is jerk, the fourth one. And you know that jerk is nothing but dA by dt, rate of change of acceleration. Acceleration equation is known to you. Your acceleration equation is nothing but s by 2 into this, s by 2 pi square upon theta o square omega square. What it will be? It's very simple. Other constant remains same, derivative of cos is minus sign, and again this term derivative. So what it will be? Yes, equation of jerk, Tell me directly. I'm not writing that acceleration again here. Jerk is equal to, yes. Observe and tell me. It's very simple. Other terms are constant. Only derivative of sine, derivative of cos term, and again derivative of that bracket term. So get it. At the end of the lecture, I will request you to upload that derivation, whatever you written on a Google Classroom. So don't miss this. Otherwise, you have to waste your 1 hour more after lecture. Yes. Equation for jerk, very simple. Take derivative of acceleration. I can directly write. Can anyone tell me equation?
Yes, sir. Right.
Yes, please.
S minus S by 2 pi
Very
cube
good.
pi cube by theta O cube omega cube sine pi theta pi by theta O into theta.
Very good. Very good. Okay. Other also tried. It's very simple. Just we need to take derivative of the cos and the term inside that bracket. That is the angle term. Sin pi upon theta O into theta. Just get multiply by one more constant. As acceleration is square, it will be cube now. And the cos becomes, derivative of cos is minus sine. So term is minus. And hence find out at theta is equal to 0 again. At theta is equal to 0. What is the value of jerk? Sine 0 is 0. So at theta is equal to 0, jerk is 0. A. Then at theta is equal to theta O by 2. Theta O by 2 means if I put this theta O by 2 here in the jerk equation, sine 90. Sine 90 is 1. So it is maximum minus S by 2 pi cube upon theta O cube into omega cube. So this is equation of jerk at theta is equal to theta O by 2 and it is maximum. And so jerk is maximum here. Why I am saying maximum? Because I know that at theta is equal to theta O, how much it is? Sine 180. Sine 180 is 0. So jerk is 0 again. So jerk is 0 at theta is equal to 0, at theta is equal to theta O, and it is maximum at theta O by 2. Now based on this information, can you draw graphs? Okay, jerk equations are clear. Hello?
Yes, sir.
Okay.
Yes, sir.
Now can you, yes, any doubt?
No, sir.
Okay. So now you have displacement equations, you have velocity equation, you have acceleration equations, jerk equations, and you know its value at theta is equal to 0, at theta is equal to theta O by 2, at theta is equal to theta O. So can you draw graphs? Anyone can try it? How the nature will be?
Sine curve and cosine curve.
Sine curve is for? Yes.
Displacement and
Okay, I'll just explain this. Similar to the last lecture, also we discussed. Okay, I'm trying to draw graphs now. You just go through this carefully. So let's say this take as a y-axis. So first I want to draw a displacement curve. I consider it for theta O. Let's say this is theta O angle. This is theta D. Remember, this is our assumption. Means follower first rise, then dwell, and then return. This is our assumption. Okay. So theta O, theta D. So let's say this angle is theta O. Here it is theta D. Here it is theta R. Now from 0 to theta O, half angle is theta O by 2. So let's say here. So this is theta O by 2. And from this to this, let's say here. So this complete angle is theta O, rise, half is theta O by 2. From dwell to this, it is theta R, and this half is theta R by 2. So let's say it is theta R by 2. Now you know nature of the displacement curve. How to get this displacement curve? Can anyone tell me procedure for this? I just explained. This is last topic we are discussing now in this. So we will end after this. Tell me how to draw displacement curve. Procedure I want to ask. The same we discussed today. The first step. When follower is moving with SHM, how to draw displacement curve?
Sir, draw a semicircle on y-axis.
Yes. Draw
Divide
semicircle on
it
y-axis.
into n parts.
Yes.
Divide
Next.
it into n parts.
Okay, that is the procedure you are telling me. So first I want to draw semicircle on y-axis, then I divide into n equal parts, then also divide cam angle into n equal parts, then take projection from y-axis, that is on from semicircle to parallel to x-axis, intersect the projections, we get corresponding points, join that all points by smooth curve, we get displacement curve. Now I will not use this whole procedure as it is here, but I will draw your curve now here. Let's say this is maximum displacement of follower during dwell, and hence this one is yes, complete displacement is yes. So at this point follower displacement is yes, at the start of the dwell, at the end of the dwell also it is yes, and at the start of the follower displacement it is here. So it is 0 displacement here, and at the end of the return also the displacement of the follower is 0. Now how to draw this in between curve, means how to draw this curve, I just explain you. So follow the same procedure by drawing a semicircle. So I just draw that curve now. It is just like this. I am drawing directly here, but you need to follow procedure to draw it. Okay. So this is your displacement curve. As I want to draw graphs for displacement, velocity, acceleration, I just draw like this. Okay. Now this is theta O by 2. This is theta O. This is dwell period. Half of the return stroke and end of the return stroke. Now tell me how to draw the velocity equations. So tell me. Here I want to draw. This is your displacement y versus theta. Now I am not writing every time theta O by 2, theta d. I just consider that same at every point. Means this one is theta O by 2, this one is theta O, and like this. Tell me now, what is your velocity at theta is equal to 0? You know equations. Tell me from the equations. This last point fast. At theta is equal to 0. Check your equation. How much velocity is? Yes, what is our equation for velocity? S by 2 sine of pi theta O upon theta O into that constant term. At theta is equal to 0, sine 0 is 0. So velocity how much?
0.
So velocity is 0, so it is here. Where velocity is maximum?
Theta by 2.
So at theta O by 2 velocity is maximum. At this point it is maximum. Let's say this value. And at theta is equal to theta O, how much it is?
0.
Okay. Means, see, if I want to draw nature of the graph, I am telling you how to draw graph. I know 3 points. At theta is equal to 0. At theta is equal to 0, velocity is 0. At theta is equal to theta O by 2, velocity is having some constant value. And theta is equal to theta O, it is 0. And how the nature of graph, how I join these 3 points? I know these 3 points, 1, 2, 3. How to join this? 1, 2, 3. the nature of curve. Yes. Yes. How to join this curve? How to join
What
this
curve?
3 point? Yes. It is sine curve. Because you check equation of velocity, the velocity equation is s by 2 into sine of pi by 2 pi theta o into omega. As the equation is having sine term, so the nature of curve is sine, and hence the velocity curve is a sinusoidal curve. And I should join like this. Okay. So this is your velocity curve for a rise stroke. What about dwell? During dwell period, how much velocity is? At the start of the dwell, 0. At the end of the dwell, 0. So in between, also it is 0. So the dwell period, it is 0 velocity. Next, for return, how much it is? How it is? So it is similar to rise, only in opposite direction. Hence for return, here it is the maximum value V max. The same value is maximum here also, but in opposite. At the end again it is 0. So nature of curve is similar to rise stroke, only difference is it is in opposite direction. So it is again V max. And how much V max? The value is known to you. It is pi upon theta o into s by 2 into omega. So this is nature of velocity curve. Okay. What about acceleration? You check equation of acceleration and then tell me. Yes. At theta is equal to 0, how much acceleration is?
Cosine curve.
Right, it is cosine curve. At theta is equal to 0, how much acceleration is? The magnitude of acceleration at theta is equal to 0, I am saying.
Maximum.
Yeah, its maximum and its value is something, let's say s by 2 into pi square upon theta o square and that value, okay. So at theta o by 2, its value is maximum. I just drawn it here. At theta o by 2, half of the outstroke, how much it is?
0.
Yes. At half, how much it is? 0. And again at theta o, it is maximum, but in opposite direction. So it is here somewhere. And as you know, the equation is cosine here. I have to draw it by cosine curve. Hence, the nature of the graph is like this. It is 0 and again maximum. So starting from 0 reaches to maximum value. At theta o it is 0 and again reaching to a maximum but in opposite direction. Then again during dwell period, you know that at the start of the dwell and at the end of the dwell, it is 0. So this period acceleration is 0. So this is your graph during rise and during dwell. What about return stroke now? You can check during return stroke, it is in same direction of rise but in opposite. So you can see here during rise, it is positive. So during return, it must be negatives at the start and positive at the end. So here its value is during start it is this much value. I'm saying this one. And at the end, it is having some positive value. If I join this, in between it is 0. So if I join this, it will be this nature, cosine curve. So join this curve. So the acceleration curve during return is like this. It is maximum. This is maximum, A max. You can see at the start and end of the rise and return, the acceleration is maximum, while at the mid of the stroke, it is 0, and during dwell period, of course, it is 0. At the last one now, jerk equation. So how the curve of jerk is? Yes. Okay, I'm drawing just above it. Yes, how the nature of jerk is, yes. At theta is equal to 0, how much value of jerk is?
0.
Okay. So at theta is equal to 0, it is 0. At theta is equal to theta, again it is 0. And it is maximum at theta O by 2. So it is having some cost. Let's say this is your, this one is your x-axis for theta jerk curve. I'm showing this one. Forget about this last one. So it is having some constant value. Let's say here it is. And as the jerk equation is sine or cosine, it is sine curve. So the curve is like this, having some maximum value and again 0. Then 0 at the during dual stroke, well opposite nature during return stroke. So this is your jerk equation. And you observe jerk is maximum at the half of the stroke. Here it is. During rise as well as return. So here it is, jerk is maximum. And how much value is known to you? That we just derived in the previous session. Okay. Any change in the graph? Anyone want to add something? By considering acceleration change at this point. You observe it, last point this one. By considering acceleration change at this point, whether jerk is 0 here, how much magnitude of jerk at the start and end of the stroke?
Theta.
Theta. Magnitude of jerk at the start and end. You observe the nature of graph, acceleration graph. In the last lecture, means yesterday's lecture, we discussed this concept. When
0.
any term, yes, when any term varies, changes its value in a 0 time, its derivative will be infinity. So here you can observe this acceleration is changing from V1, A1 to A2, let's say means 0 to A max. You observe this carefully. Acceleration is changing from 0 to A max in 0 time. What is the meaning of this? How much value of jerk at this instant, at that instant?
0.
No.
Infinite.
See, I am writing here. Jerk is what? Jerk is equal to dA by dt. What you mean by this? It is A2 minus A1 upon T2 minus T1. As we are finding at the instant, it is, let's say, dt. So you check at the beginning, means at this point where the arrow is, at this point value of acceleration is how much? It is 0 also and it is A max also. You observe this change. At that instant only, its value, it is changing from 0 to A max. Means when I am finding J at theta is equal to 0, its value is A max minus 0 upon dt. How much dt is?
0.
0. So 1 upon 0 is infinity. So remember, whenever any term changes its value from 0 to any other value in a 0 time, then its derivative will be infinity. The term derivative will be infinity, and hence as the acceleration is changing, here you can see, as the acceleration is changing from 0 to A max in a 0 time, jerk at this point is infinity. As the slope is positive here, you can see it is moving towards positive, and hence this jerk also I can draw like this. It is reaches to infinity and again becomes 0. Similarly here also, it reaches to infinity and again becomes 0. While here it reaches to negative infinity and again becomes 0. And similarly here also reaches to negative infinity, again becomes 0. So this is nature of the jerk curve. You observe, even though acceleration is finite, but the jerk is infinite at start and end of the stroke. So this is your nature of displacement, velocity, acceleration and jerk curves for a follower moving with simple harmonic motion. So we will not prefer this motion as the jerk is infinite at the start and end of the stroke. So we need to search for next motion. So uniform motion and simple harmonic motion is not suitable for a high speed application. Why? Because in the last case also, that yesterday lecture we seen, and today's case also, the jerk is reaches infinity, jerk reaches infinity at the start and end of the stroke. This is all about a follower analysis when it is moving with simple harmonic motion. Any doubt? Yes, any doubt?
Oh, sir.
If no doubt, then we, yes. If no any doubt, then we stop here.